Hello, hello. Today I would like to explain to you what a neural network is. This term is very confusing. It was confusing to me for a good year. First, I thought each nodes were like computers. They're not. Then I thought maybe those are network pieces because they're called networks. So no, they're not. So it took me a while to figure out what they really are. So imagine um, if you're writing a software program that has an array in it, right? Array is called A, and it has maybe 5 elements. Those elements don't live anywhere but in the memory, right? And in the programmer's mind, it's really in the mind of the programmer, right? So it starts in the programmer's mind, and those end up living as a memory location, each one in memory. Each one is not a computer. Each one is not a network node. They're just a location in memory, right? Now, that's how it is implemented in a real life software program that uses neural networks. It took me a long time to figure that one out because I kept thinking that they're actual physical things someplace. They're not, right? They're imaginary and they're basically saved in a memory location. Now, having said that, now I want to explain to you in as simple a word as possible as to what a neural network is. So if you look at this picture here, to the right of me, probably the left of you, I'm not sure how it's going to show up on the video. You see the blue dot. Imagine that blue dot is an army general. He or she needs information from all his or her subordinates. And these are all the soldiers along the way. Maybe these are colonels, these are captains, and these are ground soldiers, right? Now, for any given task or an operation, each one of these soldiers have a particular value. In AI, they're called weights. So between this and this, there's a weight, meaning it trusts this particular soldier only so much, whatever information he or she is bringing to this first, what are called hidden layers, right? The soldiers or captains in this layer. And this applies to every single connection in every single layer. Not only that, there's such a thing called as a bias. So once you've calculated the information that's coming up from each one of these sources, you sum them up. For example, let's look at this first blue one, right? It's getting information from these three soldiers, a layer below or layer to the left of him or her, right? Each one has a weight for a given situation, given task. Once you've calculated them all up, and this information flows, again, same relationship exists between these hidden layers, and we'll get into more detail of this in further videos. But for now, we're trying to focus and understand what's really happening, right, overall on the broad scheme of things. At the end of all of this processing, there's an output, and that output should match what the expected output is. For example, let's say you're trying to figure out if this is an example of a detection of a disease. From test data, you know if this is supposed to be a yes or no. And you do this a million times, right? And over time you learn, and you tweak these weights over time to figure out what the answer should be, right? So once you've calculated the sum of the weights and the information sent from these three ground soldiers, this particular node then learns over time, doing it 1,000 times, doing it over 1,000,000 times, what weight and what bias. Bias means it's something applied even before you take the information. You know from previous experiences that overall, these three should have a bias of whatever, right? The point is, information is sent from one node to the next to another node in the layer, and this information is tweaked over time through learning by comparing with known results, the weights and the biases and the activation functions. And we'll get into those details much later, right? When you get into details. But right now, the idea is A neural network is really imaginary in the programmer's mind, and the data is saved in memory, right? These nodes. This could be just a memory block, right? And the calculations happen over time based on weights and variations and activation functions, and those change over time based on what the true result should be in the first place. So once you've done all this and you've trained your model based on these calculations over, let's say, 100,000 iterations of this, right? Then you can create a model because now you have the weights and the biases kind of exactly right. So when this model is given new data to test on, it is more likely to have the right answer than not. So again, to summarize, a neural network is imaginary in programmer's mind, and they're stored in memory, and over time we go through these calculations to get it right. I hope you found this useful. If you did, please like and subscribe. That really helps me, and I will see you in the next video.